kit thing. All the properties inside usually are, but it itself is not. And that's true. UIKit actually adds these methods, draw at point and size, and there's a few other ones. It adds them, even though it's in a completely different framework, using a mechanism in Objective-C where you can add methods to classes without subclassing them. Okay? It's called categories. It's talk about Wild West. That's why I don't show you until about halfway through, because it can be abused, this mechanism. But that's how this is working, for those of you who are wondering. Drawing images is almost the same, but instead of an NS attributed string, you get a UI image. So you know how to get one out of the image asset library with image name. There are other ways you can create them from files. You can even draw into an off-screen bitmap to create a UI image. Once you have a UI image in your hand, you just send it draw at point, which will draw that image with its upper left-hand corner at the point you specify, or draw in rect, which will scale the image to fit in the rectangle you specify. Okay, this is a scaling one. Or draw as pattern in rect, which will like tile the image, repeat the image to fill the rectangle that you specify. Okay, and you can get other representations, PNG representations of things you've drawn and all these things. So I just want to let you know that's in there. You don't need it for your homework, but anyway. So drawing text and images, really easy. It's just attributed string and UI image, draw at point, draw in rect. Okay. What about when your bounds change? Okay, you noticed when you did the navigation controller or the tab bar, your bounds of your view got shrunk down to fit the thing at the bottom or fit the thing at the top. And also if you rotate your device, obviously the bounds are going to change. What happens when your bounds change? Well, by default, the bits of your view that were last drawn will get stretched, okay, which really is almost never what you want, okay? I mean, most content wants to be drawn to get high resolution and have it look nice. So the default is that because it's way high performance than asking you to draw again. But there's a property in UI view you really want to know called content mode. And it says what happens when your bounds change. And the one down at the bottom there, UI view content mode redraw, is doing what you imagine, which is it asks you to redraw your whole view with drawRect whenever your bounds change. Okay? So in our demo, we're going to set it to redraw because if our card's bound ever change, we want to redraw. So we get a nice sharp face card image or the right size little pips on there and text and all that. So you might want to do that as well. Okay, UI view content mode scale to fill is the default. That's the bit stretcher. Okay, so that's the drawing side of things. Now let's talk about the input side, okay, the recognizing gestures. It is possible to get the raw data about fingers touching the screen, how many are touching, where the fingers are, when they move, and it used to be that you actually had to look at all that data to figure out what the heck the user was doing, swiping or pinching. It was a nightmare. I mean, I can't believe people actually did it. It was quite esoteric code. But the last few iOS releases have had the right way to do it, which is gesture recognizers. Okay? So the way we're going to understand what the user is doing is the system is going to recognize certain gestures for us and tell us when those gestures are happening. Okay? The obvious way you would want to do this. The class that is the base for all these recognizing of these gestures is called UI Gesture Recognizer. It's an abstract class. Okay? You never instantiate it. But it has a lot of concrete subclasses like pinch gesture, tap gesture, all that. And those are the things that does the actual recognition of a gesture and communicating with you when it does. There's two parts to using a gesture recognizer. You have to create a gesture recognizer and add it to a view. You can only add a recognizer to a view because views are the ones that have a coordinate system to know where the touches were that caused the gesture to happen. And then number two is you got to provide a handler, a method to call when the gesture happens or is happening. If it's like a pinch, it's, that gesture handler is going to get called a lot as the pinch goes out and in, or if it's a pan, okay? But if it's a swipe or a tap, you're just going to get called once. Make sense? So those are the two things you need to do. Usually number one is done by a controller, although sometimes views do it to themselves where they add a gesture recognizer to themselves. And number two is often provided by the view. In other words, the handler, the thing to do when the gesture is happening or happened, a lot of times the view implements that method. So even though the controller might add the gesture recognizer to the view, when it adds it, it tells the system, oh, and when you recognize this gesture, let the view handle it. but the controller can handle it itself. So we'll do both in the demo. We'll have the controller handle it, we'll have the view handle it, the whole deal. So let's take a look at the code, what a code would look like to add a gesture recognizer to a view, a gesture recognizer to a view in a controller. So this code that I'm showing right here is in a controller. It's the setter of an outlet for a view called Pannable View. Okay, that's the name of the outlet, Pannable View. So this was just control dragged, wired up, and now as an outlet, and now we're in the setter. And in the setter, what we're going to do is when that view is set in our controller, we're going to add a gesture recognizer to that view so that that view starts recognizing the pan gesture. Pan is put your finger down and move around. Okay, that's called panning. So it's very simple. You can see that we create a concrete subclass of gesture recognizer called UI pan gesture recognizer. You see that there in the yellow bubble. And when we create it, you can see its designated initializer. All the concrete classes designated initializer take two arguments. One is the target. That's who's going to handle this gesture when it happens. And the second thing is the method to call in that object. So here, pan is going to be sent to the view itself, the same view that we're going to add this gesture recognizer to. And then we just do the step of adding the gesture recognizer to a view. The method add gesture recognizer is only implemented by UI view. So a controller can't recognize a gesture. It has no coordinate system to do that in anyway. So some view has to be handling this gesture. And yes, you can have self.view recognize gestures, right? The whole view, that's perfectly fine. And yes, the target in action could be the controller, a method in the controller. It doesn't have to be a view, okay? That can be any object. So how do we implement that target, that pan colon, right? So I'm panning or I'm pinching and I'm getting sent pan colon when I'm panning. What do I do inside that method? And the answer is that each concrete subclass of UI gesture recognizer will provide some methods to help you, okay? So for example, the pan gesture recognizer provides these three methods. Translation in view, that's how far the touch moved since basically it was last reset, okay? And it starts off reset when the touch goes down. So as you move, unless you reset it, which you can do in your recognizer, we'll show you that, it's going to tell you the cumulative translation distance from where you started, okay? So that's translation in view. Velocity in view is how fast it's moving. Is your finger moving quickly? Like it's like almost like a swipe or something, or is it moving really slow? Is the user trying to really do some detailed work? So this is telling you the velocity. And then set translation in view allows you to reset the translation, okay? Because I told you translation in view is since the last reset. Set translation will let you reset it to some point. And then the next pan colon you get, the next finger movement, the translation will be from the place you just reset it to the last time, okay? So those are given to you by pan gesture recognizer, and you also inherit, pan gesture also inherits a very important property from UI gesture recognizer, the abstract superclass called state. Now, state can be a lot of different things. Here's some of the more interesting ones. UI gesture recognizer state began means this is a continuous motion kind of thing, like a pan or a pinch, and it just started. The finger just went down, okay? Then UI gesture recognizer state changed means it's one of those continuous things, and it changed. The finger's moved, okay? Changed means it moved. And then there's UI gesture recognizer state ended. Finger went up, okay? Exactly what you would think. But there's other states, like UI gesture recognizer state, what's it called? Recognized, okay? That one you get for discrete gestures like taps or swipes. You don't get all this began, moved, or began, changed, ended. You just get recognized. I recognize the swipe. I recognize the tap. You see? See the different state there? So you recognize you'll never get on the continuous ones. Well, you might get it, but you wouldn't pay much attention to it. But on the discrete ones, that's when you look at it, and vice versa with the began, changed, and ended. You can also get canceled and failed, things like that. These happen when things like you're in the middle of a gesture and a phone call comes in, okay? Boom, that gesture just got blown out of the water. So really good code will pay attention to failed and canceled and make sure these things aren't in a wacky state if the thing gets aborted right in the middle. So I'm not going to show that in the demo because time is going to be of the essence here, but you can look at the documentation how to handle those. All right, so what would pan look like, given that we have those methods that the concrete thing provides? So I'm probably not going to do anything when the finger first goes down, because nothing has really changed yet. But as soon as it starts changing, or when the finger goes back up, I'm then going to update something inside my view based on where this new position is. And I'm going to get that new position by asking the recognizer, the pan gesture recognizer, what's the translation in the view self. Okay? Well, the reason we specify the view when we say the translation is because we need a coordinate system. Okay? We've got to know what coordinate system we're talking about this translation being. Right? So self in this case, because pan colon is in a view. Like I might set my origin or some property. This is just an example line of code. If I had a graph or something like that, maybe I'm moving the graph around, just constantly resetting the origin. And here, since I'm moving the origin from where it exists at the time this is called by some little translation, I want to reset that translation every time, so that I'm always getting little incremental translation movements, and I'm moving my origin around incrementally. Otherwise, I'd have to keep track of where did my origin start, and then every time this was called, I'd have to find the difference, and then move it that much. This way, I don't have to worry about it. I just keep resetting the thing back to 0, and so I keep getting these tiny changes, and I just keep applying them to my view. And this is a very common pattern to do this for these continuous ones, constantly resetting. And we'll do that in our demo. We're going to do pinch, but we'll do the same resetting. Okay, so let's look at some of the other concrete recognizers. Pinch, okay, pinch doesn't have translation, it has scale. So when the pinch first starts, the scale is 1.0. And as I go out, 1.1, 1.2, 1.5, 2.0, 1.5, 1.2, 1.0, 0.9, 0.8, 0.7, 0.6. Okay, that makes sense? So that's what's happening there. And then the velocity is how fast in scale factor change per second that's happening. So are you pinching really fast in, pinching fast out, et cetera. So that's giving you, again, some indication what's the user, if they're pinching out really quickly, repeatedly, maybe they're trying to really zoom out fast. You could zoom out faster than usual or something. Rotation gesture recognizer, also a two-finger thing, like a pinch, except for you turn your fingers. And it's going to tell you the rotation in radians. Everyone know what radians are, right? 0 to 2 pi around a circle in radians. Look it up if you don't know it. And that's also telling you velocity in radians per second, how fast the person's rotating. Swipe gesture is one of these discrete gestures. You just set up this swipe gesture, you allocate it with the target in the action, and then you set these properties direction or number of touches required. Number of touches means this is a swipe with 2 fingers or 1 finger. That's what number of touches means. 2 finger, 1 finger, 3 fingers, 5 fingers, whatever you want. And the direction is left to right, right to left, top to bottom, or bottom to top. Okay? So you create it, and then if a swipe happens that meets all that, you'll get your handler called once with recognized as the state. Does that make sense? So a swipe is something you don't track. It just tells you, oh, I saw a swipe. And yes, it's smart about if you have a pan gesture recognizer and a swipe gesture recognizer, if you swipe smoothly enough, it'll see it as a swipe. But if you go slower or you don't go, across, you're going in a diagonal or something like that, it'll say, oh, no, that's a pan. Okay, so it knows how to kind of tell the difference between gestures, okay, as much as possible. It's pretty cool. Tap gesture, just like swipe gesture, right? It's discrete. You set it up, how many taps, double tap, single tap, how many fingers, et cetera, and it'll send you recognized